The disadvantage of this method is that it does not allow for economic and social benefits of commercialization to remain within the country. Licensing technology to foreign producers does not generate local jobs as a domestic industry does. Nor do the products, processes and services developed by foreign countries necessarily match the requirements of the domestic market. While international considerations make it more difficult for entrepreneurs to embark on international transfer of technology and research and development outsourcing, entrepreneurs have demonstrated a tremendous ability to collaborate through joint ventures, consortia, and outsourcing. Collaboration helps entrepreneurs to distribute risk, pool resources, and tap into the necessary sources of expertise required to design and manufacture increasingly complex products. Alliance strategies have become particularly common in biotechnology, as large pharmaceutical firms with diverse products, portfolios, and powerful testing and marketing resources collaborate with smaller biotechnology firms with leading edge or niche technologies. The information, communication, and advanced electronic industries have also relied heavily on alliance strategies in order to gain access to a rapidly changing and expanding set of product and process technologies. Such alliances are likely to accelerate the pace of technology diffusion across the firms, industries, and nations. Today, I have chosen a live case to illustrate the concepts of invention, innovation, and commercialization. We will look at a startup company called Rockenbach Toy Company based in Southern California. Its founder, chairman, and CEO, Mr. Paul Eichen, used his background in robotics to branch out into a new field, the manufacture of interactive toys. He will explain how he started and developed a small business which has developed into a multi-million-dollar enterprise in less than 4 years. What inspired you to take on this venture?
Well, the inspiration really came from a love of toys and hobbyist products, and some experience with hobbyist products that I couldn't operate. In particular, a helicopter, remote control helicopter that my father gave me for my 30th birthday. And after spending half a year building it and not being able to fly it after it was built, got me thinking about how you could create products that would give you the same sort of experience, but anyone could operate them. And so Rockenbach really came from this experience of building a remote control helicopter that I couldn't then operate, trying to create products that could be operated in the home, give the same kind of experience.
Mm-hmm. Okay. Is the timing of this innovation important?
I don't think it is from a technical point of view. Even though Rockenbach is a very high-tech toy, the technologies that are employed are not state-of-the-art from the perspective of some new breakthrough in the microprocessor technology or the radio frequency components technology. There's nothing that we're doing today that we couldn't have done 10 years ago if we had started then.
So in other words, there is no sense of urgency about bringing this to the market?
Well, there's certainly a sense of urgency from the point of view of moving the organization forward to use capital efficiently, but I think as is the case many times with applications of technology, the product itself may not, you may be using technology that's been available for some time in unique and novel application or combinations, and that would be the case with Rockenbach. Rockenbach wasn't enabled by a new fundamental technology. But of course, once we got started, then there was a great sense of urgency to move the operation forward.
Yeah. As you know, most new product and process development is not initiated by new science, but is an attempt to meet the perceived market needs by drawing on existing technology and on the pool of scientific knowledge. Did you embark on any additional R&D to develop the technology?
I would say no, that all of our development was application of technology. So there was no new material science, no new semiconductor science that was required. On the other hand, there was quite a bit of novel application relative to how we used plastics technology to build our building components, or how we used both digital and analog, existing digital and analog electronic technologies to put together a very high performance but low cost control system for our toys.
Okay. Would you say that your product is the result of a market pull rather than the technology push? In other words, are you motivated to bring this product to the market because of a perceived demand?
Absolutely, the product is the result of our perception of the need to have toys that would give the experience of hobbyist toys, this ability to operate robotic machines and interact with things in a play world that you wouldn't be able to in the real world, and that the existing products were simply too sophisticated for most people. So it was trying to fill a need for a certain type of product versus some enabling technology that led us then to, oh, here's how we can apply it.
Okay. While market-driven innovations generate radically new inventions that transform markets, most innovations take the form of incremental changes to existing products and processes. Could you please explain the additions you have made to the basic product to enhance the continuing demand for a captive market?
Our whole strategy for the development of the product line is very similar to other world-class toy systems that you can see in the market. So like Lego, which is the best example of any toy system in the market, our whole strategy is to start with the foundation for our product line, which in our case is both the building system and our robotics, our radio-controlled robotics. But then each year to bring new products that enhance the same system. So if you look already just in the 2.5 years that we've been in operation, we're introducing our third generation of products, and they all work together, and each new generation is an incremental improvement. It improves the play value and flexibility of the toy system. So our hope is that year after year after year for decades we can keep adding incrementally to the system with new robotic toys, new construction pieces that will make the product line better and better for the children.
As you know, Paul, competition from existing or alternative new technologies can shrink the market for a given innovation. How do you perceive the characteristics of your product and the costs of commercialization as possible barriers to entry of others to your customer base?
I think Rockenbach has a relatively unique position relative to its competitors in that the amount of capital that we've been able to raise and bring to bear on developing this complex toy system is too much for most companies that, smaller companies that might like to imitate what we're doing. In particular, there's because it's a system and it requires the electronics and the robotics and the construction, it's not a toy system that lends itself to copying, say, one item. So, say, a popular doll or a popular stuffed animal or a popular piece of software is relatively easy to copy. But a complex system of toys like ours is much more difficult. At the same time, for the larger companies, there are really two barriers to entry. One is that the whole approach that we have of a patient, long-term build of this intrinsic value toy system, basic toy system, is not typical for the larger toy companies. They tend to want to move very quickly into products that have usually an attachment to some popular cultural event, Star Wars movie or some other movie or Disney characters. And at the same time, we've worked very hard at building a very strong overlapping intellectual property portfolio. So we have both our intellectual property as a barrier to entry for the larger companies, as well as our whole business model is not typical of the Hasbros and the Mattels and such of the world.
Okay. Could you give us the reasons for your decision to outsource the manufacturing operations all the way to China?
The company has tried to operate in a semi-virtual way in every respect, and so we tend to take on the most difficult tasks for ourselves and then outsource whatever we can, especially to help us limit the amount of capital that's required and to help us with time to market. So most especially in the area of manufacturing, we didn't want to have to generate all of the personnel, all the infrastructure and personnel required to supervise purchasing, kitting, manufacturing, assembly, quality control, etc. At the same time, there exists in southern China a highly developed industry that's made its goal being dominant in the outsourcing of manufacturing for toy companies. So we found ourselves at the point in time that we were ready to start thinking about manufacturing in a marvelous position to go to a very capable, very competent, highly developed industry in Hong Kong and southern China that makes its living in making toys for other people. And of course this industry is taking advantage of the low-cost labor in China and then of course all of the technical expertise and management expertise that exists in the Hong Kong toy manufacturing industry. So it was ready-made for the strategy that we were pursuing, which was to keep the difficult design and development tasks for ourselves, but outsource whatever we could to other competent third parties.
Do you feel there is room for improvement in terms of quality and timeliness?
There certainly is a lot of room for improvement in terms of the quality of our products over time. The Rock-and-Box system may be the most complex toys that are being manufactured in China today. And unlike our other European competitors like Playmobil and Lego, who've kept all their manufacturing in-house, we have outsourced the manufacturing of this very high quality, what we like to think of as legacy quality, products that can be moved from one generation of children to the next. So in order, as we scale up our production, in order to really have that kind of legacy quality, we're going to have to make improvements in process control with our partner manufacturer. Today, a lot of things are done ad hoc. There's a lot of hands-on fine-tuning of processes while they're running, rather than a more structured cultural orientation towards process control within the manufacturer. But we think that we can make those improvements over time, and certainly our partner is quite willing to work with us to scale up the production while improving process control and quality all the while.
You touched upon culture. Do you experience difficulties due to the cultural differences?
I wouldn't say that we experience difficulties. I think that the culture of the Chinese manufacturers have more to do with the nature of the clients that they're serving. The toy industry tends to be kind of a job lot industry because products come and go so quickly. And so if you're building a product that's going to be built in a certain finite quantity for a period of 2 or 3 years, you don't tend to build around that product a lot of the processes that are going to be longer term and pay off for you because of long-term manufacturing of the same sub-assemblies and components over a long period of time. With Rockenbach, we expect, like a Lego, we may be building the same basic components for decades. And so making the investment to bring more process control into the toy industry for this type of a product makes a lot of sense. So certainly they're not Chinese cultural sorts of issues that we face, but more industry issues where we're making a different kind of a product.
Okay. Do you feel comfortable with the process of technology transfer in terms of patent rights and other protective measures?
Yes, we feel very comfortable with technology transfer, especially because the company that we're working with has so many years of experience with other very large toy manufacturers. And so we're dealing with a very experienced company. At the same time, we've been very careful to protect our patent rights and our trademark rights around the world with a comprehensive intellectual property program within our company.
Okay. Paul, what final advice would you give to the young entrepreneurs?
I think that the advice that I like to give to younger business people that would like to become entrepreneurs, I think the most important thing is to serve an apprenticeship, to find the finest company that you can go to work for and work very hard and learn what made them a great company, what strategies, what processes, and then that stays with you in your whole career. So I think that's the most important thing, is for people to learn from masters of a particular industry and then to take what they've learned from those masters forward with them into their enterprise. This is where we started with the original idea of having robotics and construction together in one place system. So when we first started, it was really work that we were doing at home in the evenings, and I'm not an engineer, but several of my friends who were doing this work. And so you can see here the original blocks were just carved out of wood, and we made some ramps and decks and such out of lucite. And then the original robot, the base is a Fisher-Price toy, and the top, I think, is a New Bright toy, and we just cobbled them together to try the experience and get some idea in 3 dimensions of what the idea might be like as a toy. And from there, we were very encouraged, and so the next step for us was not to engineer the product, but to produce some models. Come on around here, Christian, I'll show you. Some handmade models of what the toy might be like for a child when we really produced it. And we didn't want to make the investment of really engineering and raising the money that we would need. So even though these products look a lot more like finished product, they're actually just handmade models made out of bits and pieces of things. We used servos out of model airplanes, and this is actually the type of material that many times goes over fluorescent fixtures in the ceiling, and some components out of a Lego system. But we built something that the kids could really play with and operate, and we learned a lot in the process. For instance, we had always made a system where at least some of the robots could stack things up, and it was only held together by gravity. But the children really didn't like that, because if they knocked it, with an elbow or knee, it would come apart. And they told us we really needed to make something that snapped together. But in any case, through our market research, we were really very encouraged, and we decided to go ahead and incorporate and raise the money to move forward and build our product line. And the result is what you see over here.
So in other words, you go from invention to innovation.
Actually, I think that's a very good statement, because this was a very rough kind of invention, and there were actually a huge number of incremental innovations over a period of years that were made to come up with a marketable product.
Now you're going to show us how
it works.
Commercialize.
Yes. So the idea that we always had was that several children could play with several robotic toys at the same time. So part of what we had to innovate was a new kind of radio control system, because today in the marketplace it's always one child playing with one toy, or in the hobbyist market where you have much more expensive radios and toys, they have single frequency transmitters with different crystals so that you can be together. We needed something that was both one transmitter, low cost, but for multiple children. And that technology is here in our command deck And when you start with our system, you have to buy a start set, and it comes with a command deck. And the command deck can have up to 4 of our handheld controllers plugged into it at the same time. And then there can be up to 8 RC toys that are turned on and operating in the system. And what you do is you remove one of these keys from the command deck that have a number on them, and you place it in the toy that you want to play with, the Rockenbach toy that you'd like to operate. And then on the handheld controller, you push the select button until it's got the number of the toy you want to play with, and then you can operate it. So this little guy here, it's called a skip track. It's new for this year. And what he does is he loads and transports material wherever you'd like it to go.
Any reason why you chose this design for your controller?
There is, in fact, and it's very important that the kids have an intuitive feel for the toy, and all the children have played with video games, and so both the styling of the command deck and the styling of the control pad was made to make the children feel like this was something very familiar.
We have just examined a live case study involving the manufacture and distribution of a novel interactive toy from conception to commercialization. As you have just seen, Mr. Paul Eichen of the Rockenbach Toy Company had an idea which was translated into a meaningful product. It is clear from this example that creativity leads to invention, and that innovativeness is a quality usually required and always desirable at all stages of the innovation process. Mr. Eichen has shown us that creativity can provide a forum for innovation by being one of the requirements for successful entrepreneurship. The company followed an innovation process that involved 6 steps. The first step of the innovation process is the pre-project stage. This stage involves dissemination of internal and external research and development communications regarding projects that may be of interest to the firm, as well as the process of brainstorming ideas with peers. The second step in the innovation process focuses on project possibilities. During this phase, the organization determines what type of products or services could be useful and desirable to customers. The third step is the initiation of the project, which consists of managing the idea with the marketplace. Execution of the project constitutes the fourth stage in the innovation process. The organization's focus during this stage should be on managing the innovative project. Following the execution step, an outcome evaluation should be conducted. An organization's focus during this fifth phase should be on evaluating the development of the innovation. Finally, the organization should attempt a project transfer. During this last phase of the innovation process, an organization should seek to transfer project development to the next stage for further work on the project, leading to commercialization. As is evident from these steps, innovation, as differentiated from creativity or inventiveness, has the marketplace as a constant reference point. The market determines both the value of the opportunity or the return on investment, and what the associated risks of the failure are. Organizations have developed risk analysis tools as a means of evaluating the market for creative and innovative technology ventures, with the goal of determining which technologies are worth considering. In order to evaluate the viability of different technologies, we must be able to describe what a technology is. We can describe technologies in three different ways. First, technology can be seen as the means of accomplishing a task. In other words, technology includes whatever is needed to convert resources into products or services. Secondly, technology can be described as the knowledge and resource that are required to achieve an objective. Thirdly, technology can be viewed as the body of scientific and engineering knowledge which can be applied in the design of products and or processes, or in the search for new knowledge. Technology management is rapidly emerging as a discipline combining the elements of business management and engineering. This discipline is applicable to every element of technology-oriented businesses, including marketing and planning activities, research and development, product development, and manufacturing. The National Research Council Task Force report on management of technology identifies the following major elements of technology management: research management, product planning and development, project management, integrated manufacturing processes, production control, quality assurance, information systems design and use, software development, product planning, corporate technology, and integration of technical disciplines with business and financial decision making. Formal knowledge of technology management is valuable not only for the managers of research and development, but also for manufacturing, marketing, financial and general corporate management. Effective technology management requires an interdisciplinary approach to technology management. Universities and other educational institutions should offer education and training in this emerging discipline. Let me offer a final thought on business competitiveness as a function of innovation and technology. Innovation is valid, timely, and responsive to competition. Organizations should conduct competitive analysis by asking 4 basic questions. Question number 1. What are the implications of the interaction of probable competitors' move that have been identified? Question number 2. Does the organization have opposing strategies that are likely to clash? Question number 3. Does the organization's forecasted growth rate match that of the industry's forecasted growth rate? Or will a gap be created that will invite entry? Question number 4. Will the industry structure change? It is fair to say that technology management is instrumental when applied in forecasting assessment and implementation of technologies for competitive advantage. Creating a competitive advantage can be seen as using technology to improve a process, thus reducing costs or providing customers with a best of a breed benefit. It should be clear from our discussion today that organizations must actively manage their technologies through effective invention, innovation, and commercialization strategies.